In this video, I would like to go over the concept of series, which is a concept in section 9.2 of our textbook. All right, well, here I have some examples. The first examples are relatively easy, and then we are going to work our way to more challenging examples towards the end here. All right, well, let's take a look at the first problem. The first problem, here we see the expression sigma, which in mathematics represents sum. And in particular here, it's the partial sum of the function 2i that you get when you plug in the numbers starting with 5, and then you plug in consecutive numbers into this into this expression until you get to 7. 7 is the last number that we plug in. So that is, we take the 5, we start with the 5, we get 10, plus, then we plug in the number after 5, which is 6, we get 12, and then we plug in the number 7, we get 14, and we stop there. All right, this is the 7 up here is the upper limit. All right, well, if we add all these, we get 26, 36, we get 36. So we say that the partial sum, S-U-M sum, is 36. All right, that's the answer for the first problem. All right, let's take a look at number 2. Number 2, we have a different expression, k plus 2, but it's going to work the same way as problem number 1. So we're going to take a look at this bottom number here, and in this case it's 3. So we plug in the 3, we get 3 plus 2, we get 5. And then we plug in 4, we get 6. We plug in 5, we get 7. And that's it. We've reached the upper limit. All right, so we say that the sum, partial sum, is equal to 18. Okay? So now it just so happened that both partial sums had 3 items that were being added. But it doesn't have to always be 3. Most of the time it's not going to be 3. Let's take a look at problem number 3. This is the partial sum, starting with, you plug in the 10. So we get 60. And then we plug in 11, we get 66. We plug in 12, we get 72. We plug in 13, we get 78. And when do I stop? Well, I have to get all the way to 90. Well, that takes a long time, and I'm not going to fill in or write all those numbers. Fortunately, if I want to do the sum, I do have a formula that will help me get the answer to that. It's over here. Now, this particular formula only works for arithmetic sequences. Arithmetic sequences. All right. Now, our series, that is arithmetic. Now, arithmetic means that each term that I'm adding, each consecutive term that I'm adding, it's constant. All right, there's a common difference. Let's take a look at how far away the first 2 terms are. From 60 to 66, that's a separation of 6 units. From 66 to 72, it's a separation of 6 units. And 72 to 78, it's a separation of 6 units. It'll always be a separation of 6 units. So in this case, we are able to use this formula. All right, so let's do that calculation. Okay, so we will need to know n, which is how many numbers we're adding. And let me figure that out right now. How many numbers am I adding? From 10 to 90, the answer is 91. Or sorry, 80, 81. 81 terms I'm adding. Now, how do you think I came up with the 81? Isn't it just 80? It starts at 10 and it goes all the way to 90. It's 81. Let me show you something up here. What is 7 take away 5? The answer is 2, right? But how many terms did I end up adding? 3. So it's this 2 plus 1. Let me show you that it works over here also. How many terms did I add? 3, right? Let's do this, this calculation. 5 take away 3 is 2. But then you add 1 to it. You get 3. 3 terms that I added. So if we do 90 take away 10, we get 80. But if we add that 1, we get 81. So it's 81 terms that I'm adding. That goes in there. And then, what is the first term? Well, the first term is 60. How did I get 60? Well, plug in the first number down here, the lower limit, plug it in, 10 times 6, 60. And then I need to know the last term here that I'm adding. And it's not 78, remember, this keeps going until you plug in the 90. So let's see. You plug in 90 into n, and we get 6 times 90, or 540. Okay, so those are the 3 numbers that I need. Let's plug them into the formula. So we get a sum of 81 divided by 2, and then 60 plus 540. And let me do this calculation. You get a calculator. Okay, so we go 81 divided by 2, or 40.5, times 540 plus 60, that is 600. And the answer should be 24,300. Okay, so this is a pretty powerful formula. All the numbers that you get with the function 6n, starting with the term that you get when you plug in 10, and then all the numbers all the way to 90. Okay, so that's the answer. All right, let's go to this last example. In this last example, I'm asking to find the sum of the first 20 even numbers. Okay, let's see what they look like. 2 plus 4 plus 6 plus all the way till I get to the 20th term. Okay, all right, well, the common difference here is 2. All right, so this is an arithmetic sequence, meaning that I will be able to use this formula. All right, well, let's see. If I'm going to use this formula, I need to know how many numbers we are adding. And so it'll be 20. I need to know what the first number or the first term is. And the first term is 2. And I need to know a sub n, or in this case, the a sub 20, which is the last number here. What is it? Okay, well, if you can't figure it out in your head, you can use this other formula for figuring out any specific term. And that formula is a sub n is equal to a sub 1 plus n minus 1 times the common difference. Okay, so let me do this calculation here. So if I want to do a sub 20, I use this formula, and so a1 is 2 plus n minus 1. N is 20, so 20 minus 1 is 19. And the common difference is 2, right? Separation of 2. So a sub 20 is equal to 2 plus 38, or 40. All right, so I'm going to use this 40. I'm going to use and a sub 1 to do that sum. All right, so here is the answer. So n divided by 2, or 20 over 2, times a sub 1 plus a sub n, or the last term, a sub 20 in our case. And let's see what we get. 20 divided by 2 is 10. And 42 here. So the answer is 420. All right, and that is the sum of the first 20 even numbers. 2, 4, 6, 8, all the way until you get to the 20th term. Okay, and that's it.